All right, number 26. Where is 26? Am I on the right page? Are we on page 47? Oh, well, that explains things. So this was not actually 1-7. This is going to be 1-8 today. All right, 26, trees. Trees are divided into 4 categories according to height and trunk circumference. Data for the trees in a forest are described in the table below. And so it's got dominant, codominant, intermediate, suppressed, and so on. You can read those. Write and graph the system of inequalities that present range of heights, H, and circumferences, C, for codominant trees. So codominant only. So codominant is going to be C, and those heights are from, or those values are from 56 to 72. And then for the height, oh, wait. I did that backwards, didn't I? That's the height. We're only looking at codominant, the codominant column. This is circumference, height. Height is H. My thing has a thing on it. All right, so the inequality, come on, for the height is between 56 and 72. There was, I erased it because I was looking at codominant, right? And then the circumference is between 48 and 60. Y'all, I have the sound on my phone today because there was a tornado warning in Sumter this morning, and I just want to make sure if anything goes down that, so my phone will probably go off a lot because I have a lot of virtual students, and every time something happens, I get an email. A warning in Sumter. Morning. That was in first block. At Central Carolina. Yeah, check and see. That's fine. You can check on her. Okay. All right. So then part B says determine the crown. Jane. Determine the crown of a basswood tree that is 48 feet tall. Find the expected trunk circumference. So I'm looking at basswood tree, 48 feet tall. So if I go to where 48 fits, that would fit in intermediate, right? Do you see that? Yes, this is 60. If the base, this is really just can you read a table is all this question was. The base is 48. If you look, that means the circumference needs to be between 34 and 48. I'm writing, it's so slow. Does that make sense? Yes. Number 39. Ramir. Oh, let me put the chat back on so they chat so I can see. Ramir uses his spare time to write a novel and to exercise. He has budgeted 35 hours per week. But no more than what? Wait, did she not bring chocolate? I'm recording again. All right, so 35 hours per week, but he wants to, all right, so that's how much time he has. He wants to exercise. Is that how you spell? That's not how you spell exercise, is it? No. Put this. I literally have got to go take my contacts out. I can't even see my screen. Exercise at least, right? It doesn't.
No, it's
It doesn't look right.
EXC. Yes, it is.
That's what I thought, but it's not.
Yes, it is.
I'm looking in the book unless they misspelled it. EXERCISE. Look it up and see.
Oh my God, it is spelled that way.
That's right. At least 7 hours on the exercise. No more than 15. He also to write this is aggravating. Aggravating. Between 20 and 25 hours per week. Do y'all write 20 to 25 hour a week? Okay, so what I would do is I would do these as compound inequalities, but you are right because technically it's 2, 4, and then 1 constraint there. And that's kind of what they're getting you used to is the constraints there that we're going to get to shortly. Not throw that. What are you doing? Why are you not writing down these homework problems that you did not do, Brett? It's also not helping you get a grade for your homework. All right, so look, if you want to exercise at least 7, but no more than 15. All right, I'm going to let exercise be X. I'm going to let write be Y. So I'm going to say between 7 and 15. And then for Y, I want that to be, do you see what I'm doing here, Alex, with the compound inequalities? 20 less than or equal to Y less than or equal to 25. It is, but you can just do it and shade between the 2 lines when it's like that. You see what I'm saying? So you could put for this one, and I'm going to stay in the first quadrant because we know that's where we're going to be. I would go to, let's go by 5s. 5, 10, 15, 20, 25. So between 7 and 15, about right here. Seven, 5, 10, 15, and 15. So I'm kind of shaded in the middle here. Then between 20 and 25 for the Y. 5, 10, 15, 20, 25, and here. And now let's do that very last equation. That doesn't look right here.
That's definitely not. It's a dictionary definition.
Yes, that's the one I'm fixing to do. So 35 hours per week is the most that he can spend. So the number of hours exercising plus the number of hours writing has to be less than or equal to 35. And this is an easy one to graph because both of my intercepts are 35. So I'm going to go 5, 10, 15, 20, 25, 30, 35. 5, 10, 15, 20, 25, 30, 35. I'm going to connect these. And I would shade down on this one And so my feasible region here, or my solution area, is this funny little shape right here. James, how many vertices do I have for my feasible region here? No. Four. One. This is going to be really important for today's lesson, these critical points here. These vertices. I'm only looking at the purple area.
Anyway, the orange one definitely goes through there.
It
That
does.
makes it, yeah, that makes it pop.
Those are all intersecting at the same point. You don't think so? Maybe it doesn't. If it doesn't, you're right, there would be another one.
Well, it didn't look like it.
All right.
Maybe it's an angle.
Write and graph. So that's all we had to do for that one. Write and graph. Yes or no? Yeah, it is. I'm looking at little paper balls that I'm fixing to come over there and chunk.
I don't plan to use them, but a good army is always prepared.
A good is also always prepared, Brett. All right. Somebody said 44. I'm going to do 44, and then I'll move on. If you need any other ones, I'll do for you what I'm doing for calculus. We're getting bogged down in calculus with questions and having to work them out. And so what I've started doing for them is taking numbers of ones. I'll do similar problems from a section. I'll do one or two from a section. And then any other ones that you may need, I make a little video of it and post it on Classroom if you need it with the explain solutions there.
You could just have less homework.
Oh, what?
You could just have less homework.
That would work.
Negative. Not honors. Maybe CP, but not honors.
No, but like, what is the point of having someone? Like, what does it do for us?
Practice.
But like, we don't need that much practice. Like, you're supposed to do things like 3 times in a row.
A high school, actually, it's 7. 7 forms a habit.
Well, my sister violin teacher said 3.
She wrong.
No, she's a violin teacher.
It takes 7 consecutive days or 7 consecutive times doing something to form a habit.
Well, it takes 3 to remember it. I don't want it.
I disagree with that.
Because I don't want to be going around just doing math. I just want to remember how to do it. If I do it 7 times, I'll be looking all over the place and trying to do this.
Look here, James. You're going to have homework.
It's not that much, right?
You're going to have the same amount I've been given. No matter what you say, you're not talking me out of that, and it's still counting 40% of your grade.
But that's
If you
not
turn it in a day, you turn it in after class, it's a 50.
50.
It's half credit.
What if I turn it in right now?
After I've worked them for you, that's 50.
And you didn't work all of them.
Dear
I don't think
Lord.
it's worth it. We're not gonna do all that for 50.
You don't think so? Wait till you see what a 0 does to your
The
grade.
other teachers do like 90.
Oh, man.
At least 75.
Then maybe you should do your homework because my grading is a little tougher.
I didn't get homework though. You could have told us.
Let me tell you this. You have homework every night unless it's a test day.
I don't know. But like, you're not the only teacher that says no. Or doesn't revolve around you.
It does not. But in this class, it does.
But like, other teachers assign homework too. You can't spend all day on theirs.
So you know what? There's this track we call CP. If you can't keep up with the workload and honors, there's a few items in this.
I can't, I just don't want to.
Number 44. A high school is selecting dodgeball team to play in a fundraising exhibition against their rival. There can be from 10 to 15 players on the team. Players. Uh-oh. And there must be more girls than boys. So we're looking at girls versus boys. I'm going to go ahead and define girls as X and boys as Y. Would you rather be X? Would you rather?
Wait, which
Right.
primary is the boys from?
I do not know. All right, so we know that there must be more girls than boys. So X has got to be greater than Y, not greater than or equal to, because greater than or equal to would mean if it was the same amount. Come on. If it was the same amount, it would work, and it does not say that the same amount would work. In fact, it says there has to be more girls than boys. This has got to be greater than Y. And
Wait, so if I turn my homework tomorrow, a day late, for my 60, is this going to be graded on this completion?
yes, but it's graded a little bit harsher since we've gone over the problems. Why? Because I expect you to write them down as we go. I know, I'm just telling you why my thought process there. All right, so X plus Y has got to be greater than or equal to 10, but less than or equal to what? 15. You could. The only reason I didn't here is because there's more than one variable in it, but you absolutely could. Okay, so we're just going to ignore that line right there because clearly, so X plus Y is less than or equal to 15. All right, I am going to graph. And I am still in the first quadrant because I cannot have a number of boys, nor can I have a negative number of girls. So, X is greater than Y, so I'm going to flip that around so that the Y comes first. Y is less than X, so the line, and I'm going to go by fives again, but the line Y equals X is just a slope of 1 goes 0, 0, right? 10, 15, 10, 15. And so this is what the line Y is less than X looks like. Ah, it's been dashed. Why is it supposed to be dashed? It's just less than, not less equal to. That's exactly right. Dash this. Come on over. James. Again, best laid plans, because I highly doubt this can happen when you do actually have kids. Your thoughts will change. Okay, let me graph these two really quickly. I have an y-intercept of 10. This is equal to, and so it's going to be between these two lines is what's going to happen. 10 and 15. And so I'm in between. So here is my feasible region. And so it's just to list some combinations. Yep. So anything in orange would work. Remember, I have gone by fives. So 10 girls and 1 boy. Right? 10 girls and 2 boys. 11 girls and 1 boy. Anything in that orange area will work. Does that make sense to you? Why? What don't you do? Do you understand how to graph the inequalities? You really don't?
I don't understand how you get what you get before in order to graph the inequality.
Okay, so it told me I needed a team, and it needed to have more girls than boys, and I needed between 10 and 15 players. Okay, that was given to me to start with. So I look at what my unknowns are, and I assign them a variable value. So I said, let girls be X and boys be Y. I've got to have more girls than boys. That's where that equation came from, that inequality.
So
Yeah.
for this problem, also like for like part B, it said list all of the
You don't have to list
numbers.
all the possible because there are a lot of possible. It is not an infinite number of possible, but it is a lot of possible because you could have, so this is 10, right? 10 and 1, 10 and 2, 10 and 3, 10 and 4, but you can't have, can you have 10 and 5? Yeah, you can have 10 and 5, but you can't have 10 and 6 because then you got 16 players.
Yeah.
Then you can have 11 and 1, 11 and 2. So there's a lot, but there's not an infinite number because it stays in the orange box. It doesn't go on forever.
I can't like point numbers.
You
or
can't,
like
exactly,
people.
exactly. You have to have a whole
So,
person.
yeah, I didn't write all of them, but I've given like examples.
Yeah.
I feel like it's
About what? The So I was saying to you that the boys and the girls, we define this, and this is how we got, there's more girls than boys, right? And so then I graph that. That's the yellow dash line. How do you graph the line y equals x?
Where did you get, I don't know.
So
Oh,
that
yeah,
goes,
no, I know. It's,
y-intercept
that's
of
it. Yeah, that's it, right
0 and slope of 1. That's where that came from. And then these two, it said you needed between 10 and 15 years. So the boys plus the girls, you need 10 or more and 15 or less.
there. Why 10?
Because I noticed in the beginning, it said you need 10 to 15 players.
Oh, I thought you said 10 girls.
No, it asked, part B asked you for combinations, like how many boys and girls would make this situation true. And I said, well, you could have 10 girls and 1 boy. That would work. 10 girls and 1 boy, you have more girls than boys.
How did you graph? Oh,
So this
yeah,
line-
I got it.
Cover up intercepts.
Yeah, I got it. Thank you.
You're welcome. All right. If there are any others that are super pressing for you, if you would email them to me and I will do a short little video clip on graphing them and doing that. I will find that today's is going to build on that and you'll get plenty of press. Are y'all ready?
In all honesty, no.
Yeah, you don't. I'm sorry.
You know, I do.
Thankfully, we are finally today getting into something that is outside of the Algebra 1 standards and more into the Algebra 2 standards. Yes, I'm tired of reviewing Algebra 1. I hate coming into Algebra 2 and teaching graphing lines because I'm like, oh. But we do it. All right, let's talk about linear programming. I will tell you this, linear programming, I could give you one linear programming problem and it would test every concept that we have done so far in chapter 1. You don't even know what it is yet. I didn't mean to make it sound horrible.
I don't like that. I hate
Okay, well, lucky for you, the rest of Algebra 2 is focused on quadratics and not linear.
Actually, I know the quadratic formula.
Do you?
Yeah, well, I know what it looks like. I don't remember the exact, like, variables and stuff, you know, the parentheses, and it's over something else,
Mm-hmm.
and then I know what it looks like. I know the basic structure.
All right, so here's what linear programming does. Linear programming has a system of inequalities. Come on, inequality. And then I also have a function This is terrible today. A function to optimize. Do you know what optimization means or to optimize means?
So,
If you have an optimal solution, what do
is
you
that
have?
the best one?
The best one, exactly. Right. So in terms of math and what we're doing, the optimal solution, we'll be looking for like a maximum or a minimum, something, maybe a set of constraints, okay? And this system of linear inequalities are called my constraints. And then I have a function to optimize. So maybe I am trying to sell something, and I want to take into account the cost that it takes me to buy the materials, the money that I have to pay the employees. And so those are all constraints. They're constraining how much money I can actually make. And then I take my function, which is what I sell everything for, right? Like I sell shirts for $5, so 5x, and and that's my function that I'm trying to optimize. I want to find the maximum there. I want that money made to be as high as possible. So that's a great application for linear programming. This is probably the realest lesson we will do as far as how it can be applied. So I'll do one where I'm just going to give you the inequalities, and then these will be word problems where you come up with them yourself. Now, we have some different types of feasible regions here, and I just want to talk about this for just a minute. This is what we call a bounded region. Because it's closed in on all sides. And then this, if it will write, sorry, this one, I just saw where several of my online people had asked for certain problems. If I didn't work your problem you asked for, virtual people, I will do a little snippet video if you still need it. If you will send me an email and tell me that problem, I apologize. Technology is lagging, and I didn't see where y'all were asking for problems here. I just looked over and realized. I'm not sure. I think I may have worked all those, but I'm not sure. So let me. All right. Maybe I have something like this. This is an unbounded feasible region because it's not bounded in on all sides. Unbounded. That's a terrible example. I shouldn't put that. I should have put it like here, but anyway, you get the point that if it doesn't go in one direction, if it's not enclosed on all sides. Now, what I do need to tell you, these vertices I've told you are very, very important. These are the points that we are going to use to optimize the function. Okay, so it's very important that you know how to find those points, and that's why we spent so long on those systems of inequalities where we found the points where the triangle intersect, and finding those as well. All right, let's do an example. Let's do a bounded one. Here's how it's going to look. Y'all got that? Give me wait a second. Okay, tell me when you got it. I forgot to hit the record button again. It still doesn't look like it's recording. Why is it not recording? I do not understand why I click record and it doesn't record. Okay, so this is an example we're doing, and I'm going to give you the steps first, and then we're actually going to do it. So we graph the constraint, the first three inequalities. Find the actual vertices. Now remember, this is where we probably need to graph the lines and find the intersection points to find the exact coordinates of the vertices. Plug in the vertices, and I should have put here, to your function. And the function is this one. And then we choose the optimal value. So if it asked me to maximize the function, I would choose the vertex that gave me the biggest value when I plugged it in. If it asked me to minimize the function, I choose the vertex that gave me the smallest value when I plugged it in. You have to test all the vertices though. You won't know until you test them all. So let's look at this particular one. This time I'm whole graph. And these do need graph. I don't mind if you use your calculator to find the intersection points, but I do need to see your graphs here. I'm going to come down a little bit because I know I'm... Ooh, I didn't mean to... See why we spent so much time on inequalities though? Well, you probably still don't. It's okay. All right, so what's going to be 3 and 6? So 1, 2, 3, inclusive. Pretend like this at 3, 4, 5, and 6. So right now, I'm between these two lines. Anybody confused about that? Ah, thanks guys. I keep forgetting to look over here at chat. That's why I got it up. Thank you for trying to tell me it's not recording. Yes, Chloe Taylor, that's good. Thank you for helping each other out. I appreciate y'all's participation over there in virtual land. Okay, so now to graph the next one. Y is less than or equal to 3x plus 12. So that's got a y-intercept of 12 and a slope of 3. However, because that's going to be terrible to graph. I think what I'll do is I'll just pick 2 points that are in my visible, because I'm not going to need to go any further than this, because my feasible region has to include all the colors. So I think I'll again, let's see, if it starts at 12 and then it goes up, I need to go into the negative side a little bit. For this one, if x is, let's say, let's try -3. Now, if you just got on your graph paper to go up to 12 and do a slope of 3, that's fine, and connect it with a ruler. Perfect. I just don't have room here. If x is -3, then y is 3 times -3 plus 12, which is -9 plus 12, which is positive 3. Y'all, if y'all need a little math break, it's really nasty, but mine's wet when I talk so much in mine, and I have to take a break. All right. 1, 2, 3. 3, -3, 3. Really?
Yeah, you plug in every single time you see like, yo, bro, it's spreading the coronavirus. You need to wear a mask.
All right, I'm gonna go up 3 over 1 because that's my slope. 1, 2, 3, and over 1. This looks much better. I'm solid. Solid as rock. All right, and less than. So I am over here. Confused.
And the feasible region is like really far.
Right now, my feasible region is this area.
You have another equation?
We do.
Oh.
So my very last equation here has a y-intercept of 6, so I can actually do that here. That's not a problem. And a slope of -2, so down 2 and over 1. Is my feasible, and by the way, this is shaded down. Is my feasible region bounded or unbounded? Bounded. Look at your feasible region here and let's really, let me put a bigger, here, here. Uh-oh. I hope my people are still with me. Because the internet really, really, really stinks today. It is all day.
You just say that has some.
Just for mine. For a read the book. Yeah, you can pick a choice.
Right there, feasible region. Yes. Yes, Miss McKee. Thank you. It is in fact bounded. All right, so I not done because right now I have done no more than what I did in the last section, right? This is exactly what I did last section. What my new part now is, and the only thing here really to do is I have this function that I have to optimize. So I did look at fractions and I didn't tell you to start with, but I want you to find the maximum and the minimum of this. Okay? So here's what we do. First thing we have to do is find these points. Now, if you don't want to use your calculator or you don't want to use Desmos or you don't want to do whatever, what you can do is you can look at these, and I should have probably labeled the lines so you could see. This is y equals 6. This is y equals 3. You can use this to help you. This purple line is y equals -2x plus 6. Come on. And then this pink line is y equals, God, this thing is so slow. 3x plus 12. So think about this just because this will make your life a lot easier, because a lot of your constraints when you're talking about linear programming are going to be x and y constraints, horizontal and vertical lines. So if I think out this point right here, and I need the coordinates, right? I need an x, I need a y. I already know one of them just by looking one. The pink line is intersecting with the line y equals 3. Every point on the line y equals 3 has a y value of what? 3. So if you put 3 in for y in this equation, right? 3, yes.
I'm a little confused. How did you get 3x? I thought our x was -3x.
Which one are you looking at? For the purple line?
The pink line.
So the pink line, your slope is 3. For the point that I'm looking at, I'm trying to find the coordinates of this vertex. So because it intersects with this horizontal line right here, that line is y equals 3. So I know that at this point, because it intersects share that point, then I know that the y is 3 there. I just need to find the x value of just that particular point. So 3 is my y value here, not my x value. To find the x value, I actually have to plug in. And you're actually right, it's going to be negative 3.
I'm talking about like the y equals 3x plus 12.
And what about it? Y equals 3x plus 12. Yeah, that was the original equation.
I'm confused. I'm confused on how you got the x to be negative 3 instead of just 3.
How I got the x. Oh, I see what you're saying. Okay, so I just picked a random point because if I graphed an equation in slope-intercept form, I would have had to start way up at 12 and then do a slope of positive 3. So I just picked a random x value to get started on that one. That negative 3 has no significance other than the fact that I picked an x to use to find a point on the line. Does that make sense?
Yes, ma'am. Thank you.
Are you sure?
I think so.
Okay, because remember, when you graph a line, you need 2 points. So we can graph a line by doing the y-intercept and applying the slope to the intercepts, or we could literally do an x-y chart and pick 2 points and find the y and connect them, because it only takes 2 points to do a line. I knew that my feasible region was going to be over here, so I just picked a value. I could have negative 2. I could have picked negative 1. I could have picked anything, really. But I picked negative 3, and then I just plugged it in, and I did this from there. All right, so I'm going to finish. I'm going to solve this. I'm going to subtract the 12, and I get negative 9 equals 3x. So x equals negative 3. So the point is negative 3, 3. And I already got there. So anyway, what I'm getting at is you can use what you're given to help find the point. But if y'all would, what did you get for the other coordinates? Y'all find those real quick and we'll plug in together. Thank you. With y equals 6 and this equation. And so that would be, is it 2? No. Negative, if I had 6, well, 6. Negative 2. Is that what y'all got for x there? All right, so I have 4 points. I'm going to write them up here so I don't lose track of them. These are the problems I told you will take an entire page to do. I won't cue and give you a ton of them, but you will have several to practice. 1.53. I'm still not done. I still haven't gotten to the new stuff yet. It's negative 2/6. The function that I am trying to optimize is 4x minus 2y. Okay? Now it's downhill. Now I take these 4 points that I have worked so hard to find. And again, you have technology at your fingertips to help you find that. If you don't want to do algebra the way we just did, you can always use your calculator, graph the lines, find the intersection point. Okay? Now, I'm going to go to a new page and get off of all this, because the whole point in graphing all of that junk was to find the vertices. Once I have the vertices, I'm ready to plug them in. All right, my function is 4x minus 2y. My feasible region vertices are 0, 6. So So I'm gonna plug 0 in for x. I'm gonna do f of 0, 6. And then I'm gonna do f of 1.53. And then I'm gonna do f of 3, 3. Which one? This one? Oh, is it negative 3, 3? I wrote it wrong, sorry. Thank you. Negative 3, 3. And then f of negative 6. And this simply tells me, just like if I have f of x, I ask find f of 2, you plug a 2 in for every x. Here, telling me what to plug in for every x and for every y. All right. So 0, 6 is going to be 4 times 0 minus 2 times 6 or negative 12. Almost done. The highest one is the maximum, the lowest the minimum. So here, 4 times 1.5 minus 2 times 3. Six minus 6, 0. Y'all can probably run circles around me since I have to keep waiting on this board just to write a number. There we go. For the one, 4.
Good morning, Camden High School. Please stand for the Pledge of Allegiance. I pledge allegiance
To the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Please be seated for a moment of silence. Thank you. Hispanic Heritage Month is observed over a 30-day period from September 15th through October 15th. This theme is the history of serving our nation. On Fridays, we will highlight the contributions and accomplishments of individuals of Hispanic ethnicity. On Tuesday, Felicitas Mendez was honored with a doodle by celebrating her work as a civil rights pioneer. Senior football players, don't forget to check your email and have your homecoming representatives turned in to Ms. Brennan by 3 o'clock tomorrow, Friday, September 18th. Summer assignments for Honors English are due by Friday, September 18th. This deadline applies to Honors English students for both first and second semester. All afternoon games and practices are canceled for today. Don't forget that announcements are posted on our website as well as on social media. Have a great day. Dogs.
All right, so once you find all these, you find zeros against value that you have. So 0 is the maximum value 0 and it occurs. Oh, I'm echoing. It occurs at 1.53. Oh my gosh. Here's your min. Okay. That's fine. All right, your homework tonight is going to be page 63. And I will tell you always, if I show a certain amount of work, you should show a certain amount of work. So what I'm getting at is I want to see your graphs on these because it says to graph each one. I want to see the vertices on your feasible regions, and I want to see you checking your points there. So we're gonna do, no, you can just type that into the calculator. You don't have to show your work for those. We're gonna do 1 through 6 all and leave it at that. So that's, these can take, these will probably be about half a page long. So if you turn in a page, you have probably not turned in enough. Okay? All right.